The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello, everybody. Thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kīlauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, and so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Maunaulu eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally gotten.
Aloha, everyone. I'm geologist Philip Ong, here with Mr. Dane DuPont from HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, August 22nd, 2024. Kilauea has been quite busy, extra busy this past week than she was the week before that. So we got plenty to talk about as far as that. But before we get into that, how are you doing today, Dane?
Doing pretty good. Yeah, it's been pretty busy. Last few weeks we've been talking about how there was nothing on the radar, and now there's something on the radar besides Kilauea, which has been getting more active. And now we're tracking the 91E now, tropical storm Hone, getting ready for that this weekend. So lots of different things going on.
Yeah, for sure. So yeah, we'll get through it here, and our regular update on our first half of our program. I'm going to be leading discussion in the chat and collecting questions for us to discuss. And then on a second half, we'll or maybe it's the last third or something. We'll go into the couple of anniversaries that we actually have today. Today is August 22nd, so we're going to first revisit the August 22nd or 21st to 23rd, 1963 eruption. And then we'll go to the 1968 eruption, was August 22nd to 27th. So both of those were Middle East Rift eruptions, not far from the current activity, at least where they began. So that'll also help inform us a little bit as far as some of the possibilities of what could happen with our current activity. So stay tuned for that on our back half. So anything else before we get into it, Dan, and get into our summary here?
No, I think let's just jump into it.
All right. Let's move our screen around and make it look pretty here. And get into our Hawaiian volcano summary. Aloha, everyone. This is our Hawaiian volcano summary for August 22nd, 2024. Kīlauea just had another intrusion that occurred near Pauahi Crater in the Upper East Rift Zone that occurred in the early hours of August 20th. And that followed a whole series of earthquakes that had also been occurring in that Upper East Rift Zone as well. That's just the latest development in a series of events, because previous to this intrusion, the USGS released this image, which is a ground radar change measurement showing inflation that was happening up to the day before that, right adjacent to Puʻuʻōʻō off to the side here. As well, there's an inflation south of Kīlauea, the main summit caldera. And one thing we heard the USGS describe is that the symmetrical and round nature of these signals suggests that this inflation is from a magma body that's at a moderate depth down, unlike the one we just saw that was near the surface, which produced more of this rainbow pattern and butterfly pattern there. So this is where we had inflation just at the start of the week before the intrusion. But prior to that, from last week, you might recall that we had an intrusion or an inflationary center near Pauahi Crater. And prior to that, we had the intrusion just 1 month ago today on July 22nd over at Maunaulu. And that was right in here. So we actually had an intrusion into this Maunaulu area. And then over the next week and a half or so, moved over to Pauahi Crater. Over that following next couple of weeks, migrated further over to Puʻuʻōʻō. And in the meantime, pressure returned to the summit crater, and that seems to have re-injected another intrusion and perhaps beginning the process once again. So this is the zoomed in version of the most recent intrusion, and there you can see that butterfly pattern right next to Pauahi Crater, just slightly to the north and west of the previous center, which is showing here as slightly deflating by Maunaulu. The south flank of Kilauea is still moving quite fast. This is a Kalapana Trail GPS station for the last 2 years. This north-south component is showing a faster southern motion at first, but still continuing at a unchanged rate here in the last couple of weeks at Kalapana Trail. This means that the rift zone is then able to open further and facilitate that filling of the rift zone from magma that's coming from the summit to this East Rift Zone injection site, occasionally rounding that corner, and then once it rounds the corner, it's propagating to all those different reservoirs. So Kalapana Trail is moving to the south, and at Puʻuʻōʻō itself, we're seeing effects of it getting pushed to the north and to the east, while also getting uplifted from the side from that deep magma inflation. This is one station on the north of the rift zone. If we look at the station just to the south of that at Jacuzzi, it's showing the same signals also northeast and up. So everything is moving together in a Puʻuʻōʻō area, and it's not that Puʻuʻōʻō itself is reinflating. It's that an area deep and slightly off to the side from it, but it has reached that area. If we look at the tiltmeter at Puʻuʻōʻō, it registered this signal a couple weeks ago, where it first showed the onset of inflation from the west and has since stabilized until this most recent intrusion, what we saw in the last couple of days right here. Otherwise, that eastern reservoir at Puʻuʻōʻō does appear fairly stable, and perhaps that pulse that went around a corner has stabilized. The escape road, however, just off the left side of the graph here are the last couple of pulses of the July 22nd to 25th intrusion. It has been going through very steady deflation until we had this intrusionary signal that occurred here in the early hours of the 20th. Since then, you can see that it also has stabilized and is no longer moving in an inflationary pattern. So moving back towards the summit, the last piece of this is that at the summit stations at Halemaumau and on the South Caldera, we saw deflation. So magma was leaving that summit area to feed that Upper East Rift intrusion, and that kind of ties together the story of what's happened on Kilauea over the past week and a half or so. Looking at the usual plots that we examined, these are the earthquake rates and depths for the past month. So here is that spike of earthquakes that accompanied the intrusion on the 20th. And since then, we've come back down, and prior to that, we were also fairly low levels compared to the month prior. On the map, we can see that cluster at the Upper East Rift and a little bit under the South Caldera, a little bit more dispersed on the Middle East Rift Zone, as that deep magma is pushing to the sides rather than pushing its way upwards towards the surface. We also see here on this map this 4.7 magnitude earthquake on the south flank, just adjacent to this zone of intrusion. So as the south flank continues to move seaward and magma continues to inject the Middle East Rift Zone, we're seeing movement of the flank and occasional earthquakes such as this 4.7 right here. So this pattern is likely to continue because the pathway just continues to open with more magma and more flank movement here. So that's the wrap on Kīlauea. Quickly on Maunaulu, earthquake rates are low. There are earthquakes per week over the last year, so quite low since the deep events under the summit back in late 2023. And we continue to have long-term slow inflation on Maunaulu, with the two sides of the summit caldera continuing to move further apart, distance increasing on the graph here. Perhaps there's some slight adjustments, some little wiggles like you see here in the past from adjustments and influence of Kilauea's movements, but nothing major in the grand scheme of things atop this long-term inflation. And that's our Hawaiian Volcano summary for today. Mahalo. So there's a lot to get through there. I think it would be helpful for us to hear directly from the USGS on this, and we do happen to have a clip from Dr. Ken Han, the scientist in charge, who spoke at the After Dark in a Park event on Tuesday night a couple of days ago, not quite 48 hours ago now. And as a bonus, he actually included a little update on a current activity. So I will put up our honorary After Dark in a Park overlay for him here, and I will add him to the stage and let Dr. Han give us about a 7-minute update here.
About the very unusual events that have happened here in July and August. Starting around the 22nd of July, here's the summit of Kilauea Visitor Center. We're right up in here. This is Crater Rim Drive coming here, and then you turn and go down Chain of Craters Road by all these craters. This just lit up with earthquakes on the 22nd. We have locatable earthquakes and the earthquakes that are too small to locate. So locatable earthquakes were going at about 40 per hour. And we had a lot of magnitude 3s in there as well, and a bunch of magnitude 2s. And then we had about 4 or 5 times as many unlocated earthquakes. So we're really looking at something like 150, 200 earthquakes an hour going on in this thing. And quite a few people, if you lived up here, you felt these things in late July. So this lit up, and then it migrated down, and we have the East Rift Zone, which is the zone of vents out in here. broken into three pieces. There's the Upper East Rift Zone that goes like this direction. Then the Middle East Rift Zone goes way out. And then, sorry, there are two pictures in here, so you can't see it. And then there's a Lower East Rift Zone down in Puna where people live. But these were the first earthquakes that turned the corner here. And until this time, since 2018, we hadn't seen magma make it back into the Middle East Rift Zone. So it punched its way from the Upper East Rift Zone into the Middle East Rift Zone during this event. And a shallow dike was in place. Oops. And you can go see the impact of that if you go out to the Maunaulu parking area and see the offset curbing and road that's out there. So this dike was in place sitting in between these two guys. And then the really interesting stuff started to happen. So that whole event was over on about the 25th. And then this is a satellite image using radar from outer space to actually look at deformation. And so there's a couple different ways that you can measure things. One is to use lasers, and you time the laser and you bounce it off things, and you just know how fast it's going, so you know how far it is by how long it takes to go down and come back. This is a little different. With the radar, we really can't time it. But what we can do is we can check and see if the ground is the same size as it was before, because when the satellite flies over, the waves should be in phase. So if you think of waves that go like this, they should match up identically. And instead, what we're seeing, if the ground changes, is we're seeing the waves shift. And that shift, we can actually measure the number of wavelengths it shifts. And so we're measuring by how many wavelengths this shifts. This has this ugly physics and math component to it. but anyway, it's a very clever idea. And so we use these colors in here to do this. But what it shows in here, I didn't put the one of the dike, but there was a very strong signal when the dike was formed in here. But magma started just leaking down into the Middle East Rift Zone. So past Makaopuhi Crater and out by Nepal Crater, we had this circular uplift. And so this was two satellite passes, one on the 7th of August, or one on the 26th of July and one on the 7th of August. And this is the 7th to August 19th. And now look, this circular bullseye has now moved down between Nepal Crater and Puʻuʻōʻō. So this is really unusual. The normal, if this was a dike that was going down there, there tend to be vertical fillings of magma, and it tends to make an elongate shaped deformation pattern. This circular pattern suggests that we're deep because it goes way out past the edges of the rift zone. So you have to be kind of down deep to push the rock up. If you're shallow, you can't push very far away from where the deformation is. And it's very symmetrical. So it's like a body that is being filled, and then it moved and it started filling. And these are two places historically we've known where magma accumulates. This is one, and then underneath Puʻuʻōʻō over here is another one that we've seen it accumulate in the 1960s and stuff. So we're back to accumulating magma in these places right here. This isn't really getting primed for an eruption, but if you can think, after the big 2018 thing, we took a huge amount. We took about 15 years worth of lava storage up in the summit and transferred it down to Puna and out into the ocean. And so what that did was took a kind of a pumped up system where everything was pressurized, and it sort of deflated it down. And so what we're seeing now is this system repumping up and getting magma out into here. So it's starting to pump up so magma can be transported in these sections again now. And just last night, starting at 9 o'clock, we had another flurry of earthquakes in here. And it wasn't as severe as these because we didn't see a lot of magma move from the summit out in here. But something happened in here where magma was moving for about 4 or 5 hours last night, kept us up. We kind of peaked around 2 o'clock at 35 earthquakes an hour in there. And then it kind of calmed down. It's still going on at a low. It's idling out there right now. So we don't know if it's going to pick back up again or not. And I actually haven't looked at my phone for an hour, so I don't really know if it has or not, but I don't think it has. But anyway, that's kind of the state of the volcano right now. And I can show you the these are the earthquakes for the last week out here. And so here's Kīlauea caldera. Here's the Upper East Rift Zone, Maunaulu right here. This is out towards Makaopuhi Crater and the Pauahi Crater right there. And the yellow ones are earthquakes that are 1 to 6 days old. The orange ones are in the last 24 hours, and the red ones are in the last 8 hours. So it can kind of show you how many earthquakes we've gotten in the last week there. And like I said, these are the locatable ones. The size of the dot is equal to the size of the earthquake. So there's a slew of magnitude 2 earthquakes out there and a lot of high ones and stuff like that. So that's a lot of earthquakes out in there. So things are humming still. And, you know, after we've kind of pumped up the Southwest Rift Zone earlier this year and had an eruption there in June, now we've shifted over to the East Rift Zone and it's pumping that up right now. We'll just wait and see what happens. And I think then I'll go to the last slide, which looks like, there we go. And we had a.
All right. So let me get this back on stage here. There we go. So mahalo for that, Dr. Han. That was awesome to have him give that update impromptu at the After Dark in the Park. We since have gotten this image that they released, which shows exactly the area that he was talking about right in there. So we showed you guys right up top of the update. So we'll go into our monitoring now and show you what the USGS has said in their text update today, the most current one. They do refer to that magnitude 4.7 earthquake that occurred in the south flank at a depth of 4 miles below sea level, with no apparent impact on either Maunaulu or Kilauea volcanoes. They do note that the activity is still elevated near that Upper East Rift Zone site of intrusion, but at a decreased rate. And so they still say that any changes in character and location can occur quickly, as can potential for eruption, but there are no signs of imminent eruption at this time. And no significant changes in the Lower East Rift Zone or the Southwest Rift Zone there. So we still have 75 tons per day of SO2. That's the background volcanically. It can certainly affect nearby areas, especially in the national park, but fairly minimal impact for what we can have here from Kilauea. And otherwise, earthquakes are still ongoing at their lower rates there. I'll scan down here and note that they have updated their analysis here. The Upper East Rift Zone unrest since the 20th represent another pulse of magma being supplied to the Upper East Rift Zone following the intrusion that occurred on July 22nd and 25th. Currently, the Middle East Rift Zone has not shown signs of increased unrest. However, magma has recently reestablished a path to the Middle East Rift Zone, and unrest could extend to the Middle East Rift Zone with continued magma supply. So that's kind of where we are right now, is wondering what comes next. Are we going to see the same sequence from intrusion to propagation around the corner to intrude that Makaopuhi area first, then the Pau, and then Puʻuʻōʻō, all those different little reservoirs along the rift zone? Or will we pressurize and lead to something near the summit or in Upper East Rift itself, or possibly back in the Southwest Rift? All those are still connected systems of the magma reservoir now. So that's the updated USGS update, daily update here. We'll go to some of the signals now, starting with tilt at the summit for the last week. So we did have on the 20th in those early hours, this deflationary signal punctuated by these occasional earthquakes that are also ongoing with that intrusion. And you see that really lasted only part of the 20th here before it stabilized and has really been at that similar level ever since there. Maybe showing little variations, but that's all background on top of the signals we're looking for here. So it's basically been stable here. The overall size of the signal was only, looks like maybe 3 or 4 microradians. So it wasn't a very big signal actually, but it did register here. And when we move to the month-long plot, you'll see that in a little bit better scale here. But for now, you can see that coincident with that deflation at the summit are earthquakes and that band in the shallow zone coming in. The Pahala earthquakes, as colored in blue here, are still ongoing at their normal background rate, it appears. So those are the ones over here, all the blue ones, the Pahala. Nothing in the Southwest Rift recently. All the Upper East Rift, Middle East Rift ones, and a couple of deep ones. These green ones are deeper events as well. So this one right here, maybe not Pahala. There's another pathway, like a route of magma to Kīlauea that approaches more from this direction. So maybe there are deeper effects of this movement of magma in the near surface. Maybe it's actually allowing other material from deeper down to move, or adjustments of the ground in any case that cause earthquakes to occur. So that's the earthquake map for the last week here, and the cross-section on the flank of where that event occurred. Here's the last month, and there you can see within that context the size of the deflation we had and the current stabilization following this event on the 20th, and how that compares to the one we had about a month ago, which lasted 3 days. And actually you see the size of it coming out here. It's not quite fully on here, but it was a bigger signal just from what's left already than what we saw recently here, at least at the summit. Right? At the summit, it was able to accommodate that without a huge drop in the ground tilt. Not just the summit by Halemamau, this blue line over here, but the South Caldera as well. It seems to be following that same pattern. It looked like it might have been inflating a little faster prior to that intrusion. But since then, they have both been following that deflationary to stabilizing trend. Now scroll down here. There's that earthquake graph we saw at the start with the counts. Similar counts, but also not as high as what we saw a month ago. But over the course of the year, we have earthquakes per week added up, and so they don't really show up individually like that. You just see that you had some earthquakes happening the week prior, and in total, this week actually exceeds last week as far as the number of earthquakes. Right? Not as much of the one that we had 4 weeks ago. And over the last 5 years, you see we're really been ramping up. A lot of adjustments. This is really a time of ongoing adjustment at Kilauea Summit. You heard Ken Han talking about how it pumped up the Southwest, pumped up the summit, pumped up the Southwest Rift, and that's pumping up the Southeast Rift. All that is adjustments and movements of magma and pushing rock back up, and all that is all the earthquakes, and that's what this big ramp up here at the right end of this graph over the last 5 years actually is showing. So yeah, interesting times, and we may be in an era of really dynamic, short adjustments, and we'll just have to enjoy the ride. So that is the signals on the earthquakes. On the distance GPS, these are slightly different GPS plots. We're taking 2 different stations and measuring the distance between them now. So we are able to maybe absorb some of the error that you sometimes get, since it's a derived measurement here. And when this line is going up, it means the 2 sides are getting further apart. Magma is filling beneath Halemamau and expanding the ground to drive the caldera walls apart. And just recently at the very right end here, this very most recent point, appears to maybe have shown a little bit of deflation, maybe the last couple here, which would correspond to the signal we saw in the tilt as well. But that will likely stabilize and then pop back up as well too. You can see the signal from a month ago was a little bit bigger than what we're seeing so far here. And on the East Rift at Puʻuʻōʻō, here is the reason we've been looking at this graph for years and years and years, is to look for this signal that finally is here. And we're seeing that there is an increase in length between the north and the south parts of the rift zone, right? So that's the kind of thing that would make you suspicious of, well, why is it getting further apart north to south? Does that mean magma is going in between it? Is that what's wedging them apart? But as we know from looking at the previous images, both NPOC and JCUZ, both those North Puʻuʻōʻō and Jacuzzi stations, are both moving northeast and upwards together. And it just so happens that one of them is moving slightly further and faster than the other to drive this distance to increase a little bit here. So there it is. We'll probably see a bigger signal if we see magma injecting through there. We're still pretty zoomed in on the scale on this side when you look at it closely, actually. So that's the update on the GPS here. We can get into more detail in GPS to see exactly what each block of land is doing. But because things are so dynamic, we actually can look at tilt this week as well. So 2 days at Uekahuna, fairly flat, not a lot of change, fairly stable since that intrusion. We looked at the 1 week and we looked at the 1 month already here. Kīlauea is showing similar deflation and stabilization following the intrusion here on both of its azimuths. Sand Hill, we noted South Caldera and Halemamau signals as well. And now the escape road is the one we see the most signal actually from this intrusion. So when you look here, the scale of this is 50 microradians per box. So that's massively zoomed out here. So it's hard to tell because we scrolled off the previous signal here, but you can see that there's the last couple of pulses, and the other ones were about the same size, something like that, right? So the scale of change recently at Escape Road is much greater than we had at the previous intrusion. It could be that this is because this is actually closer to the station slightly, maybe affecting it in a more impactful way. Or it could also be that maybe we've wiggled the ground and we've seen all these new cracks opening up in an area. We've heard that USGS and the National Park reporting cracks are opening. And maybe if you have the ground not so locked in but loose, maybe that also facilitates it moving further and faster to have a signal like this. So but it was short and sweet, and this could have led to an eruption potentially, but it had enough space to stretch and then to just go back to doing what it was doing before. And so we'll just keep watching and waiting. At Puʻuʻōʻō, I was curious as well to see what happens exactly at that time. So zooming into the 20th here, this is a signal to the reservoir from the west that's actually swelling Puʻuʻōʻō up. It looks like it deflated very, very, very slightly, very briefly, and then has come back up and recovered it. And that south flank earthquake jostled it, but it seems to be still receiving magma and swelling to the west of Puʻuʻōʻō there. Moving further down the rift zone, at the Janaka station, we don't see any signal like that. What we do see is one giant jolt from the earthquake, that 4.7, that shook a lot of the island and then back to where it was before. And that's it for our tilt signals that are meaningful here. So to look at the GPS for the last 2 years, I think I really want to use this map from the USGS where I can click and show you guys where it is geographically, but what I'm finding is that it's not actually loading the links fully. So let's see, maybe I can make this work still, right? So we can basically summarize, maybe I'll do it half and half. I'll pull up this set of graphs from the USGS here and just show you the summit stations. They're all going upwards and in our usual patterns that they do when they're inflating, right? So up and up at Byron's Ledge in the east, and up at Outlet in the south, and up at Crater Rim in the southeast, because that whole summit area has been inflating, as we saw through that InSAR image there. 1.5 miles out, it's resumed inflating a little more slowly, right? So we saw that this was a little bit more stabilized or flat a couple weeks ago, but the swelling of the summit has broadened its base and now is reaching out to that 1.5 mile out range, just showing how we were pressurized and ready for something to happen, and we have since seen the intrusion actually happen. So a little bit of cheating there, knowing the result already, but that's the signal we're seeing there. On the Upper East Rift itself, this is that connector pathway. Puhimau has been moving up, and you can see that the signal northward just took a jump. So you can see that the intrusion happened to the south, so it got shoved to the north, just like the last time I got shoved to the north as well. It doesn't look like it was quite as far once again, but similar kind of pattern, and not a whole lot of other changes otherwise. This is a zoomed in station that's not been online for quite as long, right next to this one. So it's really the same signal zoomed in. And there you see that double jump pattern once again. So Devil's Throat has maybe stabilized a little bit. It's going up slightly over here. And Maunaulu is really noisy. It's hard to see. So those are really the Upper East Rift. So we just looked at the summit. Everything is going up all around here. That 1.5 miles out goes all the way to here. So that's the zone of swelling. Here is where it got shoved to the north at Pauahi. And let's zoom in a little more right in there. And here's Devil's Throat that's been somewhat stable right west of north and west of where that intrusion occurred, right through there. If we go further east, that's Maunaulu, where it's noisy. And let's see what we can do over here, right? So first, let's look at the south flank all the way across. So the goat pen, oh, I can't do it that way. Let's try it like, let's see. Try this. Sorry if I zoom it in here. Is that big enough? It's not really that big, is it? And I'll go back to my graphs. Okay. So let's look at the Middle East rift, since that's what's next here. Near the rift zone itself, Kana no Yohamo, you see that it was actually moving west very quickly, has slowed, but is still moving. It was moving north very quickly, slowed, and has renewed that movement. And as far as upward movement, it's still rising, actually. Maybe slowed a little bit, but continuing that uplift pattern there. This station is adjacent, so a very similar signal as well here. But you can see, maybe look at some of these patterns, really how spread out the data points are, similar to what we saw before. So more rapid movement, and we'll see this catch up over the next few days when GPS graphs update. We only get one data point per day on these graphs, so these take a while to catch up to the activity, and it's usually looking a little bit further in the rearview mirror, and still useful to really see what's happening in a big picture. Slightly further east, 10 miles east of the summit at Nepal, Station Kane and KERZ. These are also two adjacent stations, with this one on the right being more zoomed in, maybe less easier to look at over here. So you can see, once again, it's still moving pretty quickly to the north there. And it has been moving to the west, stabilized, moved quickly, and seemed to stabilize again. So actually, this was moving ahead of that intrusion, it looks like. And so this is slightly separate, right? That's that zone to the east. All the different reservoirs filling separately. So now we're seeing that phase shift. It's not matching up to that intrusion. So that's Nepal. Nepal, look how fast Nepal is still rising over there. Still going up pretty fast. Doesn't seem to be any change or slowdown in that rate. And what's interesting is that if we track from west to east, we can see that the areas in the west have a longer period of time that they were rising. And then further over we go, we see that it comes on a little bit later, and a little bit later at Kamoamoa, and Okita's too much noise, but we go to Puʻuʻōʻō, and it happens a little bit later over here. Jacuzzi's right next to it. And we can actually go all the way to RKAR, 15 miles east. This is another 3 miles east of Puʻuʻōʻō. And now that signal is showing on a northward component of push as well. Most recent one to develop here. A couple miles east of that, not quite so clear that we're seeing it there yet. There's some noise, so we'll maybe wait and see what happens there. So the effects are really spreading. So let me come back to the map, just show you where these are. I'm going to zoom this out again. So Puʻuʻōʻō is right here, right? So we're seeing the ground rising starting over here, and then moving to Nepal, Makaopuhi, Nepal to Puʻuʻōʻō, and RKAR is all the way over here. So over here, this station is getting pushed to the north also from all the swelling and action happening over here. So it's really spreading, it's bulging from deep down, and that InSAR graph might be widening the size of that bullseye as far as how far it's affecting the ground. And here's the one slightly farther over that's maybe not showing it quite yet. So we'll keep an eye to see how far the ground pumping up, as Ken described it, how far that progresses during this particular pulse. So that's all the on the rift zone itself. Let's keep going past our 931 to the Lower East Rift. Jonica, no signal at all. NANT 25 miles off the summit, no signal at all the way down there, either near Pahoa. So on the southeast flank itself, this is the Idaho station right there. So when we're wondering how far did the ground actually move, here's where we can actually start looking at some possible measurements. And it's hard to tell because, like I said, every circle is 1 day, and you're seeing that these are not 1 day events, right? So we might have one big earthquake that occurs, but actually, besides the earthquake, the ground is still moving before, possibly after too, right? Or maybe not as much before, but certainly after it's unlocked there. And you can see in this case, it looks like it's maybe about 1 box worth. So that's 5 centimeters that it moved during that previous intrusion. And the one we have now, it might be maybe half of that. So maybe a couple of centimeters where this particular station moved to the south. And this far off the rift zone, we're not seeing any upward push or east-west push as much. This one's closer to the south, but more of this north-south push right there. That's the interesting signal. So we're going to also go west to east. So there we see that signal. Here it is, PG2R, also showing that not quite as clear. Makaopuhi. We don't really see that 2 pulse there. It seems to be doing something a little bit different. Right? That block's moving slightly differently. Kilauea Trail is one that we previewed in our summary, which is really still shooting pretty fast to the south there. Pretty impressive to see it keep on moving there, right? Kilauea Trail, let's go back to our map just to show you where we've been going across. That's the GOPM is moving to the south. Here's PG2R is moving to the south. Kilauea Trail is right here, moving to the south pretty fast. And we looked at this one, MP3R, previously last week, and noted that it had not been showing any southern movement. But by this week, if we keep going past Holeipale, which is still moving also, and go to MP3R, MP3R is now showing a massive southern movement as well. And so that effect finally reached there, further over to the right in the graph. But in a place like this, for example, we're going down. So 1, 2, 3, 4 boxes. So that's 2 centimeters by this scale. So it's just really zoomed in too. It's similar to what we saw further to the west. Yeah, so there it is. And we keep going further east. And actually, there are no other stations further east than that one on the south flank. That's the last one over here. So we don't really have anything else to show further than that. So going back to our GPS now, we can go further towards the ocean. Apua Point, Kaena Point is impressive because Kaena Point is getting shoved to the south as well. And got shoved to the south during that first intrusion. Looks like it might have gotten a little bit more during this previous one. And down there, you're looking at maybe 1 centimeter based on the scale here. But maybe it's getting pushed more to the west. Presuming this is not noise. We'd have seen there be noise in these very most recent data points. So we'll see about this here. But Kaena Point on a map is down here. And so we just had the earthquake 4.7 right there. We know this whole flank is moving. And we didn't need an earthquake to tell us because we have a GPS station right here showing us that it's actually been still moving all the way at the shoreline from all this injection of magma deep into the Middle East Rift all through here, reaching all the way to the coast. So that's a whole lot of movement on Kilauea's Middle East Rift and middle south flank right through here, central south flank. And to recap that, we'll go through these once again, right? That's the composite we made showing that first intrusion that then moved over, some more. And we now suspect it's moved over possibly some more as well. Right? Maybe it's all the way over there. Maybe it's expanded. Who knows? We'll have to wait and see the next imagery there. The image that we did receive today is showing a little bit of inflation still ongoing over here in this area, but not showing us anything further to the east. Rather, this was focused on the opening at Pauahi Crater here. Right? And we're lucky to actually have this capture August 9th to the 21st with good weather on a northward traveling satellite, which was actually different than the ones we've been getting previously that have been traveling the other way, actually. So pretty cool that we actually got, for once, 2 snapshots in the same week from 2 different directions of satellite passes. That's the 21st century volcano monitoring. So yeah, there it is. Once again, Puʻuʻōʻō, right? And as Ken said, probably not a blade, but some deeper, rounder body. And just off to the side, deep under Puʻuʻōʻō there. And to continue going back in time, just so we can continue back with that, there's that previous image when it was back by Nepal. And before that, the intrusion at Pauahi. But let's go before that. Before that was inflation in the South Caldera to the Southwest Rift, and an intrusion to the June 3rd eruption that had happened before that. So you really can see all the different reservoirs bouncing around there. And so we can go back one further, all the way back to January and February of 2024, where similar intrusions and dike opening all the way down the Southwest Rift. We've got a lot of InSAR images this year, which has been awesome. I like to see the big picture, and it's hard to beat InSAR's spatial coverage here. So that's the monitoring on Kīlauea. We can check in on our earthquakes. Here is the earthquakes colored by depth, just for the last 2 days to see where we are. There's still some Pahala events ongoing. Here are our Kīlauea events that are dominating the map. And there's that cluster to Upper East Rift. Only a few Middle East Rift earthquakes, and it's really South Flank in orange here, and some aftershocks and follow-on knock-on effects as well. So that's one version of the earthquakes we can show. And we also like to show the earthquakes colored by time. So the red ones most recently, but here is the whole last 7 days. And we can zoom in a little more just to show you guys. And we can also then sort it by largest magnitude, which tells us, unsurprisingly, the 4.7 by Fern Forest. 500 responses of where it was felt. And you can see it was felt as far as Oahu. Looks like someone in Kauai had a report, Molokai, but especially in Puna, South Hawaii, and even look all the way to Kohala, had some reports as well. So that was the earthquake we just had, and USGS did issue a information statement when it occurred last night here. So no apparent effect, 4.7, 4 miles down below sea level. Aftershocks possible in coming days to weeks. So that's the earthquake update. And we'll step through some of the other usual offerings. Our volcanic hazard summary from the VOG Measurement and Prediction Project, VMAP, from Manoa, and their forecast. Zoom it in for you guys here. We're getting some changing winds with the coming storm. So you might see or smell some traces of VOG or gases in areas they don't usually smell in here, but they're not coming out at very high concentrations. This is still showing 300 tons per day as an output, but really we saw it 75. So, but this still can show you where the gases would be brought by the wind. So still South Hawaii and West Hawaii, and really when the wind and water comes, VOG will be the least of our concerns. And if you're wondering why we show these VOG updates that are not so exciting every week, well, there were many, many years of Puʻuʻōʻō where every day it was really bad VOG, and it's kind of, those of us that saw that, is a little refreshing, and it is nice to see it be nice for long periods, and we're just documenting that as well. That's how it is right now. But it has been completely opposite for a long, long time. So there's our hazard summary. Let's wrap that one up here. With the national park summary, everything in the green, and all monitors all day in the green as well. So all good in the park, but if you are a sensitive individual, follow their guidance, of course, in case something does change. So we'll wrap up Kīlauea here as far as the current stuff with some observations. We can just look down the East Rift Zone webcams. There, everything is happening underground, but still visualize what it looks like on the surface. East flank of Puʻuʻōʻō, maybe now also seeing some tilting from that swelling off to its west. West of Puʻuʻōʻō, down in here, is where we saw that magma body swelling deep, deep underground. Maunaulu camera, Makaopuhi Reservoir, all through here. And south flank by Puʻuʻōʻō, which is this area that I was drawing arrows at, moving oceanwards all through here to allow room for magma to inject the rift. So those are all the visible parts. We can work our way back up to the summit. Here's the summit a little earlier today. Nice blue skies, still a lot of mineralization on that crusted lava surface of the previous lava flows and lava lakes at the summit. And if we're curious about, is there anything hot under there, the thermal camera is not picking up anything unusual, just the usual cracks, putting out their little traces of heat. So we'll leave it at that as far as webcam views, but also point out the USGS has also been going and maintaining webcams. Here are the USGS scientists visiting KW camera to replace the desiccant packs to keep the webcam enclosure dry. Quiet at the caldera despite Upper East Rift earthquakes, and once again, more observations and photographs with not a webcam are always good to have as well. So that's the USGS imagery update, and we'll just quickly touch base on Maunaulu here. Maunaulu looked like this earlier today. Clear skies, lava filling the crater. Can't really tell what's 2022 and not just visually or from any kind of heat anymore right here. Just in case anyone's wondering, that's how it looks. And its signals over the last week dominated by the earthquake that occurred early last night, late last night, early this morning. In that summit area, very few earthquakes over the last week, more so over the last month, where we really see this long-term slow inflation of Maunaulu summit, with corresponding earthquakes in that background as well. And rates very low and per day. We've having 1 earthquake per day. Looks like all week we might have had 5 earthquakes in that area. So pretty low. There it is, pretty low, 5 per week. And looking at per month, we're really quite low. Here's a comparison of what we saw in the buildup in the years ahead of 2022's eruption in Maunaulu and the months preceding it as well. So we're nowhere near any of that, and it's just long-term filling at Maunaulu. So that's how it looks. All right. Before we take our break, we'll just mention the couple of volcano watches. There's one from, I forget if we covered this one last week, the PIPES program internships. So nice to see the internship program through UH and HVO. That one's posted for you guys to read. And if you're interested or a student, then definitely go and check that out, because you can see what kind of things, cool things you might do and how you can get into these programs, like the PIPES program, specific internship programs for exploring science. It's not just geology. They do all kinds of things in a park with different groups through the university. So awesome program. And the one from today is volcanic tremor or distant earthquakes, distinguishing signals. Just going to show a little bit more of the nuances of earthquake signals. A T phase is interesting energy dispersal. There was a big earthquake that occurred in July. Let's see here. Magnitude 7.4 earthquake deep beneath Chile on July 19th at 3:50 p.m. Hawaiian time. Produced strong shaking in Chile. It was also recorded on HVO. The earthquake produced a strong hydroacoustic signal, sound wave through water, called a T phase, which was recorded throughout the whole Pacific Basin. T phases are different from a tsunami wave and are not hazardous to people, but they do move at almost 3,400 miles per hour. And so take only 2 hours to get from Chile to Hawaii. They go through a special part of the ocean where the waves can move that fast, basically. When it reaches land, it's converted back into a seismic signal that looks remarkably like local volcanic tremor on the network. So how do you tell them apart? I'll cut to the chase here. When you look at tremor on the right, and you look at all these different stations across the island, Wood Valley, Hualalai, Puʻuʻōʻō Crater across the whole island here, you see tremor pops up at exactly the same time at all the stations right there. Whereas the T phase, actually, if you were to draw a line here, would actually be inclined with arrivals coming later and later the further away you get from Chile. So on the Kona side, Hualalai, it's arriving very slightly later than at Wood Valley, which is very slightly later right, than Puʻuʻōʻō Crater all the way over here. So that's what makes it tricky to like look at any one station, look at signals and see what's happening exactly where, right? So if you see like, if you guys look at spectrograms, for example, and you see it all coming in at exactly the same time, that's telling you that it's local. That's why those things are useful to see all side by side. Something to add, Dane?
Yeah, just curious about differentiating noise. So like a generator or something nearby that would be running, that would also not appear on all the different stations. So is that how they would address something like that? That's too localized to just one station, therefore it's noise?
Yeah, and there are other characteristics of the signal also, right? I mean, the signals are all essentially just a bunch of numbers, and so they can do all kinds of mathematical processing and filtering, and kind of analyses on a signal to see like, does it have a characteristics of noise or what kind of noise? And so over time, there's a big database of those kind of things. Yeah, and so yeah, but your easiest layman solution is if it's only in one station, something localized. We've used that before to say, okay, that actually looks like wind instead of tremor, or maybe it's two stations,
right,
but it's not enough stations, right? And yeah, those kind of clues. Yeah, good point. So that was Volcano Watch this week, and a couple of final things before our break is just our community corner. So community corner, we need to note that the Chena Critters Road is temporarily closed to vehicles due to road damage in a national park. You can see here the park staff measuring these cracks, how deep they are, how wide they are. Closure begins at the intersection of Crater Rim Drive East and Chena Critters Road at the Devastation Trail parking area and continues all the way to the coast. The road remains open to bicycles and pedestrians, and the campground is accessible, but only by biking or walking in. So nice to see them keep that access open to pedestrians and bikers, but be aware if you're visiting a national park. And if you did miss our After Dark in the park from Tuesday that talked about how the park is transitioning and all these closures, there's a lot of construction happening. They announced that the visitor center is going to be closed for the next 2 years. They'll have a temporary, what do they call it here? Temporary services. Yeah, I think it's a temporary structure near the historic ball field adjacent to the Kilauea military camp. So on a map, that would be kind of in here, right? So instead of actually getting visitor center at the front, you come in a national park, if you go all the way past the steam vents to the military camp, and there you'd find the national park building, visitor services. So just a quick on-screen review here, like all the different things that are happening across the whole park, all different timelines. Visitor center is not closed quite yet, but is expected to close as early as next month. So we'll see how that goes. And we will try to continue to bring you guys programs, whether it's from the park or other venues around, to continue our programming for you guys. So we'll keep things rolling here. All right, Dane. That was the first half, our usual update there. And I'll pass it to you.
Lots to cover in there, lots of activity. So thank you, Phil. I'd like to start off by just thanking everybody for tuning in today, your likes, subscriptions, the shares, all of that stuff, just commenting on the video. That all helps with the algorithm. I know we mention it all the time, but I'd like to, aloha that. And we'd also like to thank the Puna Strong and Kilauea Recovery Grants put on by the County of Hawaii through HCF, Hawaii Community Foundation, and their support there. I'd like to bring on Lou, who's helping us with all of this, our fundraising essentially, and heading that up. So I'll bring him on here and talk a little bit about it. Hey, Lou, how you doing?
I'm good. How you going?
All right. Yeah, so
let me get this over here. Yeah, like Dane just said, thank you to everybody that's donated. Remember, you can donate on our website at hveri.org/donate. We are a 501c3 nonprofit organization, so your donations are tax deductible, and our website is the best way to donate. Sorry, I'm a little hoarse tonight. Sorry about that. Thank you to all of our sponsors there, our partners, our collaborators, anybody who helps us out. It really takes us through all of this and helps us along the way. That's about all I got. My voice is just wrecked.
Yeah,
Sorry about that.
No worries. Thank you. I mean, you're just getting over the bug. So appreciate you stepping in, Lou, and doing this. And
You got it.
yeah, I think now we can get into the second half of our program here. So I'll
Absolutely.
bring Lou back on stage and sayonara.
Phil?
Lou, till next time.
You got it.
There we go. Should be set up. So yeah, I'd like to thank everybody one last time. And if you would like to make a donation, again, hveri.org/donate, best way to do so.
Do we have any questions we want to bring up for discussion?
We do. Let's go ahead and look at some of those. So some of these I think you might be able to answer, but some are going to be maybe not so easy. So I feel like this is reiteration of something that you already talked about, but let's just bring it up anyways, if you don't mind. Joe asks, is this a pattern that could lead to an eruption similar to Puʻuʻōʻō that stays in that general area with eventual ocean entry staying far away from the Lower East Rift?
The easy answer is yes. That's basically it, Joe. Yeah, I mean, so you have in this area lots of short eruptions. We're going to talk about those next. Some of those happen in the 60s, but they are also punctuated by long eruptions in this area. Puʻuʻōʻō was the longest one, but prior to Puʻuʻōʻō, Maunaulu was erupting for about 5 years in the same place, and that's also pretty long. So both of those eruptions are good examples of long-lasting eruptions that follow this kind of pattern of reestablishing path to the Middle East Rift. Yeah, and there's one little older one too, Heiheahulu, which is a little closer to the Lower East Rift boundary. So it can happen further down towards, maybe above Kalapana, right? Which Kalapana kind of sits underneath that lower part of the Middle East Rift, but not really further than that, right? Further than that's kind of a different pattern, a different dynamic, and it's a different thing to get into the Lower East Rift past Heiheahulu. So yeah, good point, Joe. Yeah.
Yvonne on Facebook asked, do we know how much slippage happened during the South Flank earthquakes? It was the third South Flank earthquake within a few weeks.
Yeah, good question, Yvonne. I don't know about the instantaneous event there. I mean, maybe if we had like an InSAR from the coast itself, and we could see like how far the coast has been shifted, that might be one way. That's a lot of times what they use InSAR for in places that are not volcanic. They're trying to measure fault motions. So that might be one way to do it. But I think the easiest thing is just go to the GPS and say, okay, besides the earthquakes, let's just look at all the full sequence of it, right? And then we saw that it was basically like 2 centimeters one time and 1 centimeter the next time. So you're looking at a few centimeters, maybe 5 centimeters over the last 3 weeks or something. I can pull it back up. Where is it here? Let's find a close by station, like it's been going for a while. Oh, let's look at Kalapana Trail. Right, since it started, this looks like it's about, I'll call it negative 0.01, and it's down here to call it 11. So it's gone 10 centimeters at Kalapana Trail in full over the last probably 4 weeks.
Yeah, last month, something like that.
Yeah.
Good amount of movement in a short amount of time. It doesn't seem like that much, but when you think about it, like that's a lot of movement really quickly. That's why the roads are not looking so great on Chana Craters.
10 centimeters, yeah. That's like maybe 3 inches or so.
Yeah.
Is it more? Yeah.
Definitely get some cracks that start appearing. And Yvonne was out there and was saying that some of those cracks are, but near Devil's Throat, are measuring about 6 feet deep and are continuing to widen. She was down there today just with a measuring tape, checking them out again. So awesome to get that report. Yeah.
Yeah, sure. Yeah. Yvonne's been posting great stuff on Facebook too, documenting her adventurous tracks in national parks. So check her out.
Share those on the Hawaii Tracker Facebook page if you're not, or Facebook group. Sorry, if you're not a part of that, definitely check that out too. You can see all kinds of stuff people are posting, eruption images from last year at this time, or roughly. So always good stuff. Do you have a little more to add on that question, or want to move to the next?
Oh, we might have an extra centimeter at Makaopuhi. That's about that, about 10, 12, about 4 inches, maybe slightly over 4 inches.
All right. Nicholas asks, what kind of quake was that magnitude 4.7 last night? It's strike slip or what?
No, they're usually well, so I don't have the diagrams right here, right? They're usually like what we call like a Dekomand earthquake, right? So it's like a flattish slip surface under the island. Now these are typically start off being sloped away from the island, right? So then it would basically be like a normal fault, like an extensional movement. But what happens over time is the islands actually grow really heavy and they kind of sink the ocean underneath them. So that original flat surface that was ocean sediments, that all the lava and volcanoes are on top, that's the really weak stuff you can actually slide really easily. That's usually your fault zone. That thing is bent inwards now towards that heavy center of the island, which means that when a side's pushing out, it's going to actually travel uphill now, right? And so it's almost like a little thrust motion there happening. A little technical and complicated there. So, but it's basically like a flattish fault surface, unlike a strike slip would be a vertical one where it's moving side to side. Right, so it's kind of flattish, and then it's moving one or the other, like with a slight angle, right, going up. Although it's on a surface going by gravity in a normal motion, and at depth it's going in a thrust motion as well. So we'll leave it at that, Nicholas. Hopefully it's not too much.
Right. Do one more. Nicholas also had one more. How much magma moves or circulates per microradiant normalized?
Well, that's a good question. I think that is a question we maybe could answer like for a specific location and instrument, right? So like I think like for certain eras of the Hale Mau shallow chamber, they could actually do the calculations over time, and they were getting similar. Then they could use that kind of thing. But the problem is that when a system changes, you have to kind of recalibrate, right? And we don't really know since 2018 collapse what anything is doing anymore, right there. So
doesn't the depth signal play into it too?
Exactly, that's the next thing. Yeah, the signal is affected by the depth as well, right? Proximity to the instrument. There are other things as well, so it's hard to really gauge exactly how much magma. But I'll see if I can come up with a better answer longer term than that, and give an example for some previous eras where it's been calculated more exactly.
That's probably the best way to showcase it, is where they were able to determine it and have confidence in it. Just highlight those as opposed to
I mean, there's a whole section in the back of the USGS professional paper 1806 that talks about how you take your tilt signal and then get to like a flux rate and volume too. So you can actually go through, if you do have access to that online, Nicholas, 1806 is a professional paper from USGS. And then I don't know which appendix it is. It's in one of the appendices. But yeah, I think that's where I would go look for next time.
Cool. And that does it for questions. We can get into the two historical eruptions, huh?
All right. So yeah, we'll do a little celebration of that. What was it, 61 years ago and 56 years ago, maybe? So let me get the chart up on the screen here. I might have done some bad math there. It's getting into the minutes here. All right, so what I have here is a table of Kilauea's historical eruptions from the USGS. I want to pull up our volcano awareness presentation, which is what we're doing now. So this is a table of historical eruptions from the USGS, and I'll highlight here, this is the 1960 eruption of Kapoho, right, on a lower east rift. And I'm curious to examine a period that comes after that. So beginning here, February of 61, you can see that there were 3 eruptions. There's different columns here, but the start date, how many days it lasted, and where it was located, right here at the summit. So the first 3 at the summit, and then in 61 in September is when we had that first rift zone eruption, and that one actually reaches into the lower East Rift Zone a little bit. That first one that follows, that summit restoration. And then we have 62 in December, 63 in August. That's one of our anniversary ones right there. 63 in October, 65 in March, 65 in December. Those are all in that upward and Middle East Rift Zone. All those right through there. It's like that's that phase that we're in right now, where that's the kind of thing that could actually happen. In the middle of all this, they actually had this 9-month summit eruption from 67 to 68 all through there, right? So there still is pathway to the summit, still possibility of summit eruption, just like we still have now. And then in 68, they go back to their Middle East Rift Zone, August 22nd. There's our second anniversary there. October 68, February 69, and then finally in May 69 is when the Maunaulu eruption begins. So that's the landmark 5-year eruption. That's a big one. So between Maunaulu in 69 and Kapoho in 1960, really the summit eruptions in 61, there actually are 9 of these Middle East Rift Zone eruptions in that decade right there. 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's a lot, right? And look at the lengths of time. 6 days. 15 days might have been the longest one. About 2 weeks. 5 days, less than 1 day. 10 days, 1 day. 2 days, 2 days, 2 days. Right? So usually they're fairly short. They're on a side. And volumes of lava, that's what's all the way on the right side of here. And this is in millions of cubic meters. So less than 0.01, less than 0.01, less than 0.01, 0.01, 0.02, less than 0.01, less than 0.01. So what you're seeing is there are very small volumes. These are not big eruptions that occur. This kind of activity does produce lava on a rift zone, but they're usually not very widespread, not very much of it. Here we go, some more 0.01, 0.02, and that's it, right? None of them is very big compared to our long-lasting or other eruptions there. So that's a little bit of the menu of where they are. I thought I could come back to our professional paper 1806 that I was just talking about, but we're going to go into this chapter of the 60s here. And so at the top here is our tilt magnitude at the summit. And this very top bar right here is actually indicating when you had eruptions and intrusions. The eruptions are in solid filled colors, and the intrusions are in these open boxes, and the Kīlauea has this little pound sign on it right there. Right, so what you can see here is 3 summit eruptions following that collapse of the summit Kapoho eruption. Then we have an intrusion, summit intrusion right here. Then we start having East Rift intrusion, East Rift intrusion, East Rift eruption. We'll have a year go by, East Rift intrusion, East Rift intrusion, East Rift eruption. East Rift intrusion, Kīlauea intrusion. East Rift intrusion, summit intrusion, Kīlauea intrusion. No eruptions either of those times. Until a little later, well, here's an eruption on the East Rift Zone. And again, intrusion, eruption. Summit intrusion, eruption. You see the pattern here, right? They usually come in these batches. And so here we are in this batch of intrusions, and would not be surprising to see it lead to an eruption at some point. But if so, the eruption is likely to be short and not produce a lot of lava if it follows the previous pattern. Summit tilt, whenever we have East Rift eruptions or intrusions, drops by a lot, right? You see this is looking like 20 or 40 microradians. Sometimes it's a little less, 10 microradians, 20 microradians in there. But every single time, that's the signal you're seeing on the tilt there. And then this next panel down through here is showing how many earthquakes and where on the south flank, with circle being far east, square being central, triangle being central, and pink being in the west, right? So you can see it's basically all in a central and eastern area right through here, all these earthquakes. And they ramp up coincident with these intrusions as well. So a very similar pattern to what we're seeing here today. Now, ignore the other parts of the graph and move on. So here's a map of where those eruptions actually occurred. So a plus sign, summit eruptions, February, March, and July, 61. Then East Rift eruption. September 61 is the one that actually made it down into the Lower East Rift. So that's this red one right here. Middle East Rift, Middle East Rift. This little dashed line here, this is the official USGS seismic boundary of different zones. MER is Middle East Rift, LER is Lower East Rift. So seismically, this is the boundary. And you can see that it actually made it over into that Lower East Rift quadrant, but didn't actually go very far or do very much because it was in that pattern of not very much volume. So that was 61. December 62 is this blue squares. August 63, only an Pauahi Crater right here. That's one of our anniversaries. That's it right there. Then that's followed less than a month later by the dark green triangle was all through here. Several years go by. March 65 almost retraces that very same pathway. December of 65, all through here. So those are the ones through the first half of that decade right there, just showing you a little bit of where it's all happening. And you can see that's right where we're at now. Here's our bend in a rift zone, and our intrusion just occurred over here and over here. And there's the reservoirs that are filling right now. And it's these reservoirs underneath Makaopuhi and Napao and Puʻuʻōʻō that are the feeding sources for all these dikes that are erupting at the surface here during that decade. So step one is to pressurize that whole system. Then you can refill those reservoirs, and then you can build pressure in the reservoirs, and then you can erupt them to the surface. And then when they're ready, they can do that many times for short durations. There are periods of intrusions. Here is 1963. Intrusions all, and here are all the earthquakes, all in a Kīlauea southwest rift as well. Right, there actually was an intrusion into this South Caldera and Southwest Rift area in May 63, followed by intrusions into the Kauai a few months later. Right, does it sound familiar with what we've seen recently? Right, so that's some more parallels. And then here, they have south flank earthquake swarms. Depending on activity in the rift zones, they're seeing the south flank activate and start moving off. Right, so all these are earthquakes. The circles are all on a 0 to 5 kilometer depth. That's that, and open circles as well. That's that top half and bottom half of the flank, and there they all are right here in the same section where magma flows right here. It pushes to the side. Here's all the flank earthquakes. We're seeing all these right now, also same as before. And it's a very similar pattern there too. If you look further in this document for what else was happening in the 60s. That's about the end of it, unfortunately. So here's what that page looks like. It talks about the big eruptions of 55 and 60, which were hugely impactful to people on the Lower East Rift. Had some really unique magma chemistries coming from deep Kīlauea falling into that bucket as well. So that kind of relegates the 1960s to this little corner way down over here, where I'll show you what they actually say about this whole era. The activity between 61 and 66 is similar to the earlier 20th century East Rift Zone eruptions, 1922 and 23, and intrusions in 38. During that time, both Whitney and Uakahuna vaults were in use. Tilt measurements were consistent, and the vector is defining inflation and deflation around sand spit. That's near the sandhill. Sand spit got covered by lava later. The pattern of inflation before rift eruptions and deflation with rift eruptions and intrusions of this 56-62 period is similar to that of later post-61 periods in which deformation data were more numerous and locations were more accurate. So they're sharing here that their data isn't that great either, right? This is before the network was really that great. And that's it for these 60s eruptions, really. And here it goes off to talk about some other stuff, but so it's too big a topic. There's too big a hole to fill for us to cover every single eruption of these through there, right? So that's where we're going to focus on these anniversary ones. And we'll start with Pauahi. Pauahi was a very contained eruption, filled the crater. So the professional paper 935A that was put out for this is titled the solidification of Pauahi lava lake, because the eruption was so short, most of the science was done about it actually hardening and cracks and all of that. And so this is by Dallas Peck and Willie Kinoshita. And let me just get to the abstract here. where we can recount what actually happened here, right? What actually occurred. I will note that when I was going and looking, summit collapses is referring, I think, to these big deflation events on the tilt. I'm not sure how much actual collapse is going on there, but in any case, think of it that way. So after the seismic episodes and summit collapses of May, July, and early August of 63, Kilauea erupted on an east rift zone in and near a Kīlauea crater from August 21st to 23rd, only 8.5 months after the December 62 eruption in a nearby Kīlauea crater. Eruption began at 6:10 p.m. After nearly 4.5 hours of summit deflation, tremor, and many earthquakes. Fountains open on the floor and north wall of a Kīlauea crater, feeding lava at rates as high as 2.3 times 10 to the fifth cubic meters per hour. I'm not sure what that corresponds to, but if it's total to swimming pools, it probably be just as abstract. So the lava is coming out pretty fast, pretty hot, and forms a growing lava lake in the southeast pit of the crater. During the last 12 hours, the eruption winds down to put out no lava. Temperature goes down by 20 degrees, which leads it to stagnate, and it all ends at 8 a.m. on the 23rd. But not before much of the lava that was filling that crater drains back into the vents, leaving only a 15-meter, 50-foot deep or so pile of cooled lava right there. So most of this documents about the actual cooling patterns and solidification and how lava cracks and all those kind of patterns. So I'm not going to go into that. I want to just pick out some highlights for you guys here. Here's what that area used to look like before Maunaulu buried everything. So you went from Hiaka Crater to Pauahi Crater to Kīlauea Crater to Kīlauea Crater, right? And Makaopuhi. So now both of these are gone, buried by Maunaulu's eruption, and Maunaulu sits here in between the two like that. Just for reference there. And in case you're wondering how the roads were situated, that's on here too, right? There's the map of the road going to Chinook Craters Road. It goes down to Makaopuhi Crater, where there's a little loop, turn around, and that's the end of the road at that point in time. So, okay, here's a map of a Kīlauea crater zoomed in and where the actual fissures occurred. Fissures occurred up on the upper edge of the crater, and then across that northern wall, down onto the crater floor. So that's why the lava poured down into the crater to form a lake. Once these vents became dominant, then these ones over here shut off. So this flow extent is fairly limited compared to how much lava was coming out from here. And even these ones, eventually, the upper ones start shutting off also, and it comes out the bottom and fills the lake from these lower vents as well. So that's where it actually looked, how it actually looked on a map view. And let me share here a little bit of the build up too. So, okay, here is where we get some more details and context of what might be similar today. So remember, this is maybe the third of that sequence. This is the third of that sequence of 9 eruptions. So there have been other eruptions happening before that. And after the previous one, the summit begins uplifting almost immediately. That continued until May 63, when 8 million cubic meters of lava moved from the summit into the southwest rift zone, accompanied by harmonic tremor and many shallow earthquakes. The intrusion of lava produced extensive new cracking along a zone extending 5 kilometers from Puʻuʻōʻō to a point 3 kilometers south of Halemaumo. Also sound familiar? Collapse of the summit ceased on May 12th, and rapid reinflation began, continued until July 1st, when another 8 million cubic meters of magma moved, this time from the summit into the eastern part of the Kīlauea fault zone. This produced extensive cracking and deformation along the Kīlauea fault near its junction with the East Rift Zone. That's right where Maunaulu is there. Uplifts began again on July 2nd, continued until August 3rd. Right? So you're having a whole month of inflation there, when nearly continuous tremor and earthquakes were recorded at Kilauea as another 2 million cubic meters moved from the summit into the upper East Rift Zone near the junction with the Kauai fault zone. Again, another intrusion, second intrusion. If volume calculations are even approximately valid, we can infer that most, perhaps all the lava erupted into Hawaii from August 21 to 23 was derived from lava stored in a rift zone after the collapses of May, July, and August, which meant that what they're saying is it was all the intrusions that fed this eruption that came a little while later. The magma basically moved to the area through the intrusions and then got remobilized to erupt after a little while. So the first indication of onset was tremor. They see that, we won't go through all the little details of how it actually unfolded there, but they see the fountains opening. They label them in order here, A, B, C, D, E, F, G, H, I, J, K. You can see it's straight down the wall of the crater, feeding the lava lake in there. There's actually was an overlook. You can see the rail, the metal rail here at the overlook. You're looking down into the Kauai crater. And they're in daytime looking down. So by this point in time, you see the lava is coming out of just the buried vents under the lava lake on a crater floor. And it seems like you see some fume coming from up here, but I don't see lava emitting from here and flowing down, which it was doing earlier. That was the first phase. And there is a little more zoomed into that back wall. You can see some more of that fume. There's like a little bit of like a little spatter rampart almost right in there on a wall, and all these different piles of spatter from each of these little vents piling on each other against the wall there. And bursts of lava. Well, the fissure was having to erupt through the lake in those later parts of the activity. And then there where it actually fills that the whole crater bursting from the far end over there. So yeah, I'll get some more pictures here in a minute. I think I have that one in higher resolution, in fact. But so here we are in the last few hours of the eruption, looking for an overlook. They see at 9 p.m. the lava lake starting to stagnate. 10:45 p.m. 11:15 p.m. and then that is that. There's once again that far wall. Let me see if there are any other images in aerial view looking down at the fissure line, more or less through there. And they were really interested in, I'll just show you guys like what was happening as far as in that cooling lava lake. What kind of features do you get? Pressure domes on the side like this, right there. The cracking, when was the cracking occurring? At what point in the cooling process? They mapped out all the cracks. They actually talked about the settling of the lava lake surface over time and circulation. Did I miss the circulation one? No, not yet. Circulation of that lava within that pit. Different kinds of textures. Here's a circulation. Like the lava coming to the edge of the crater, circulating down and looping back up, spattering up. Secondary cracks forming after the fact. See all the cracking. And at the time, this had not been done before. So this is why this was an important contribution here. But most of this is not about the eruption. So I was just finished scrolling through and turn the pictures we do have. So I showed you guys a map. Here's an image from 1962 of Aloi and Alai crater. Maunaulu would grow from these steam cracks right through here later on. But here's a road going by Aloi and Alai craters. Overlook and then continue on to Makaopuhi from there. So there is the probably most famous image of this eruption. August 22nd, 1963. This is 61 years ago today. And the textures all through there. And the burst at the far end there. And one more that we have. There aren't a whole lot of images on it that I can find, but this one maybe a little bit more zoomed in and better resolution. You can maybe see here a little bit better these features on the far wall, like the spatter and lava flows that came down off of these little vents. There's one, there's another one right there, and here's that far into the lake that was actually bubbling up when it was still going. Right, and see if I can scroll it higher for you guys. I can't make up much past here in black and white. But there's another little view. So that was a 1963 eruption. And since we are getting on in time here, I'll just move on to the next one, which is 68. The 68 eruption was number 7 of our 9 eruptions in this decade on the Middle East Rift. And this was documented in professional paper 890, which is by Dallas Jackson, Don Swanson, Bob Koyanagi, and Tom Wright. So in this one, yeah, there's actually a little note in here thanking, let's see if I can find this here, thanking one Jeffrey Judd for providing many observations and accompanying Swanson on difficult forays to vents 4 and D through F out here in that very remote part of the East Rift Zone, all through here. As far as they know, knowledge of eruptions downrift of Nepal is dependent almost entirely on the generosity and skill of the Gila-based Civil Air Patrol, which provided overflights for staff members and made numerous independent observations, especially at night. They actually, yeah, so thanks, go on from there, but just to give you an idea of what they were actually doing there, right? So let me come up here to the abstract of this one, the summary version of what actually happened here. So the eruption of August 22nd and 26th, 1968 began in Hiaka Crater on the East Rift Zone. In 3 days, activity migrated 20 kilometers, that's 15 miles, down a northern margin of the active part of the Rift Zone, venting in 6 different places. A 27-meter, we're going to call that there, maybe 75 feet, 80, 90 feet deep pool containing about 90,000 cubic meters of lava forming Hiaka. Only 3.5 remained after drain back into the fissure. The total volume remaining on the surface, about 13,500 cubic meters, is the smallest net output of lava in a historic Kīlauea eruption. So even though this thing went all the way 15 miles down, it put out the least amount of lava of any eruption, even though it had one of the longest cracks, which is kind of interesting to think about there. We talk about where the lava comes from there. And then that following 6 weeks of rapid reinflation of the summit, another East Rift eruption occurred on October 7th along a more or less continuous lines northeast of Makaopuhi. This would be number 8 of 9 there. So that's not quite what we're interested in, but since they come together, we'll just look at that briefly here too. So the August and October eruptions were accompanied by severe deformation at the summit and along the rift zone near the site of eruption. The summit subsided, tilted inward, and contracted as magma was withdrawn from the reservoir and moved into the rift zone. Maximum vertical displacement at the summit was about 20 centimeters, horizontal displacement about 16 centimeters. Multiple centers of deformation shifted location with time based on tilt there. So let's see here. Parts of the East Rift Zone adjacent to the fissures were uplifted during eruptions, at least 35 centimeters in August and 20 centimeters in October. A subsidence trough, probably a keystone graben, formed along the August fissures. So we'll show you a picture of that, right? So after it formed, the rift zone was still moving, opened a crack, and the whole flow that just formed was able to break and fall in partly. So that's the summary of 68 there, and we'll look at some of these images here too. So what we have in, let's see here, is this October? August and October. So August is in numbers and October is in letters. So August began at Hiaka Crater right here at 1, 2, 3, between Hiaka and Pauahi. Maybe a little segment here too. And then 4, not far off Kananoiohamo on the north part of that lava shield right there. Okay. There's 4 over here by Kananoiohamo. And further cracks 5, 6, 7, all the way down by Kīlauea. So even though lava only came out in, I'm sorry, this is so that's the August. Yeah, so 15 miles down all the way to here, but still not a whole lot of lava. In October, it was all in between this 4 and 5 zone right here. So when we look at the letters, here they are, A, B, C, D, E, F, right there, filling the Pauahi Crater. West of the Pauahi Crater, this whole area that is now Puʻuʻōʻō didn't exist as Puʻuʻōʻō then, and east all the way close to Kilauea. So that's the map of the area here. Let's move on. I won't show you guys the tilt or the zones. They have a lot of different graphs as far as deformation in here. The images aren't the clearest, but these are what we have. Lava lake in Hiaka Crater, 8:40 a.m. on August 22nd, 1968. So that's the 156 years ago. And then lava lake draining by 2 p.m. that same day. They highlight tree molds, fuming cracks, right? So remember, not a whole lot of lava came out, but tons of fume seems to be what was the view of the time. And they note here that that was sometimes difficult to locate vents buried by younger flows, and so they look for spattered draped branches of ohia trees like this to see where the vents must have been nearby. And they're a very narrow fissure in the middle of the forest with a little bit of spatter all around it. Some dead trees right next to it and some live trees not too far away still, right over there. So that's some images. And I think I'll just show you this kind of deformation graph where they're showing essentially, this is their version of, they didn't have InSAR back then, but they're showing deflation of the summit and inflation of that rift zone right through there. Right? So they're actually going through and doing leveling surveys, right, along these benchmarks and measuring and then drawing the contours and extrapolating this data from those transects. That's how things used to be done before satellites. So that is the 68.
Sounds like a lot of work that compared to now. A lot of hands-on work to get that kind of stuff done, out in the field work with a scratch pad of paper type of thing. Now it's just wait till the satellite passes over tomorrow morning and we'll get a new InSAR image, and the GPS already is coming in. And
yeah, the forest areas are still just as tricky though, right? And that's true. Still guessing a little bit. And so here they, you can see like there's no data over here, but they're like, yeah, we think it probably does this. And that's where you'd have your InSAR with the trees covering that piece of land or whatever. That's
true.
Interesting, right? Still watch out for the big cracks in the rift zone. They will eat people if you're not careful out there, right? That's I used to always joke about. There's no bears here, there's no lions or cougars to eat you, but the earth will actually eat you if you're not careful.
Next door, it ate a D9
right up.
bulldozer.
Yeah,
and they had to take it out piece by piece to get it out of the hole. I've heard so many stories like that over the years.
So yeah, the different interesting. This is back to October, but more lava trees, tree molds. I don't know if you can see very well here. All these different lava trees in an area here. So lots of lava trees were common, right? That's something when you have short eruptions in forested areas, you can make a lot of lava trees and they don't all get knocked over by some giant flow. So that might have been a common feature of many of these eruptions. They have here lava pouring into a neighboring crack, a fissure, a segment of the fissure just east of the vent by Nepal, and lava pouring back in the vent and draining back away. Something else you see fairly commonly. And where's here? This is the one where you see lava flow south of vent E, cut by a wide graben. So this is like a trench that collapsed across this flow and a whole landscape as magma moved from this area, likely further down a rift, right? And when it happens, the rift zone widened. When it widened, the top kind of fell in a little bit like a keystone, basically. So there is that. That's 68. I think that was the last image that I really wanted to highlight in this paper, but I do have a couple of images, not exactly from August, but this is September of 68. East of the escape road, one of these reef cracks opening up, venting very sulfurous gas, obviously. Lots of crystals right there, and you can see there are trees growing right where that crack is. We're in a process of dying right there. We have the October 68 eruption itself. Here's what that actually looked like. And a little grainy, but in color. A long fissure line, a big channel being formed from that one, flowing downhill. And one last one, and I believe this is by Don Swanson, image of a glowing tree mold at Nepal that looks like a heart. So a glowing heart tree mold. There. So that was also from 1868. So with that, we'll wrap it up there, and we can discuss it some more, Dane, or we can say your goodbyes as you determine.
I'm muted. Sorry. Yeah, I think we covered as much as, I think we needed to. It's always cool to go back through these old parallels into the activity that we're seeing currently, right? Because that was the thing is, at points I had to remind myself he's talking about the 60s, not right now, and describing, because it sounds so similar to your update that we did just before that,
Yeah.
It's great to draw comparisons. And a lot of people keep asking, like, is this the return of Puʻuʻōʻō? It's like, well, it's more like the return of the 60s first, which could lead to Puʻuʻōʻō, but it doesn't just skip right to 30-year eruption in the Middle East rift zone type of thing. It has a process. It has a building up to type of thing. It can go quickly, some of those steps, but it still has to take those steps.
Yeah, I mean, Maunaulu is the one you should be thinking of, right? It went all these eruptions, and what came was Maunaulu for 5 years, and then did some more stuff, and eventually you had a magnitude 7.7 earthquake in 1975, which opened a pathway further from Maunaulu to Puʻuʻōʻō, and then you had Puʻuʻōʻō that followed all of that. So that had another big influence of the south flank moving as well.
Right. And
that's always the issue, right? Like, what's driving the car? Is it the magma pushing? Is it the south flank pulling? Now they're kind of bouncing off each other. Like, there's just so much space on the dance floor there.
It seems like people are caught in a lot of people that I've talked to are caught in the most recent happenings. So they're thinking Middle East rift zone. It either comes down to the Lower East rift zone fairly rapidly, like 2018, or it parked itself there for a few decades, like Puʻuʻōʻō. It's like, no, go back a little bit further, and then it's very wild what's happening.
Most of us didn't live through that. At least you and I, Dan, didn't live through that, right? To remember the 60s, right? I do have Jeff Judd, talking about it, all his adventures a lot, and hopefully we hear more about that in the future from him and Don. It's just a different era, right? It's like, most of us in the era of social media and television and documentaries and all that have seen the Puʻuʻōʻō era for the most part. It's kind of steady, constant, always in one place. We didn't see it bouncing around a lot. It was just kind of always there. So that might seem like normal, but really that was less usual than other periods of time when you might have had tons of eruptions in that same.
And it's hard to explain to people that like grew up with Puʻuʻōʻō and only Puʻuʻōʻō, like me, where it was like Puʻuʻōʻō existed before I was here, and every day it was Puʻuʻōʻō, right? And then all of a sudden you tell them that Puʻuʻōʻō is not the normal. It's like, what do you mean it's not the normal? It's been the normal every day I've lived. Like, so it's just those geologic time, I guess, being able to grasp it.
Yeah, good point.
All right. Yeah, I think that gets through everything. Thanks for diving us back through some of the relevant history. And, thanks to Ken Hahn for throwing that little juicy tidbit update into the presentation at After Dark in the Park. If you've missed that one or you want to catch the full thing, we've tossed it into the chat. I think we could post it again, too, into the chat one more time. And yeah.
All right. Well, thanks, Dane.
See, it's trying to stay dry this weekend.
yeah, everyone stay safe out there, stay dry, take preparations against the wind and possible flooding, especially if you're in a Puna side. Seems to be the projected largest impact for now.
We are in a tropical storm watch starting at 5 p.m. when we went live for Hawaii County. So Civil Defense is going to be putting out updates. I know the Mayor Mitch Roth just put out an update as well on Instagram. So those are the guys to really listen to in these type of storms and systems coming in, especially where this one wasn't seen so far out. It kind of haphazardly got its way to be into a tropical storm. It was a week ago not thought to be anything, right? And now all of a sudden it's something.
Coalesced. Yeah. Yeah, interesting. Well, thank you, Dane. Thank you, Lou, in the back end. Thank you guys all who are chatting and conversing away and participating, asking questions, and supporting us with your likes, shares, subscriptions, and all the things that Dane mentions all the time. So do all that, like he says. And unless something happens more dramatic, like lava on a surface, we'll be back next week on Thursday at 5 p.m., our regular time, Hawaiian Standard Time. Anything else you want to add, Dane, before we sign off? No, you're muted again somehow.
Oh, yeah, just stay safe, everybody, on the east side of Big Island this weekend with the storm coming in. And I know we haven't done many of these dances this year. It's been a quiet hurricane season, so we get our first little bit of action here.
Yeah. Right on. Well, mahalo, everybody. Hui ho until we meet again. From HVERI, the Hawaiian Volcano Education and Resilience Institute, nonprofit, I'm Philip Ong, Dane DuPont, Lou's on the back end. Mahalo, everyone. Let me find the right button here. Okay, where is it? Okay, there we go. Okay. Aloha.